All right, this screencast is going to be on not only astronomy in our solar system, but it's going to focus on the inner rocky planets. And these are often referred to as the terrestrial planets. So we'll be looking at Mercury, Venus, Earth, and Mars. So the composition of planets, gases, hydrogen and helium, those are the melting points that are near absolute zero, right? 0 Kelvin. These two gases were the most abundant constituents of the solar nebula at the early phase as accretion and coalescence was taking place as our solar system was forming. Rocks, these are principally silicate minerals with metallic iron, which have higher melting points, right? These exceed 700 degrees Celsius, which is 1300 degrees Fahrenheit. And ices, these include ammonia, methane, carbon dioxide, and water. They have, let's just say, intermediate melting points, right? Water melts at 0 degrees C, or 32 degrees Fahrenheit, which are a long ways from absolute zero, from where hydrogen and helium have their melting points. So each of these are going to be composed of, well, let's just say different percentages, but roughly the same ingredients. So they're going to have similar DNA, not the same, but different, similar DNA, but different evolutionary phases. So if I look at Mercury, and here's a picture of Mercury in its surface, and here's a thermostat, if you will. Mercury is the innermost and smallest planet, hardly larger than Earth's moon in our solar system. Mercury revolves quickly, but rotates slowly. One full day-night cycle on Earth is 24 hours, but on Mercury, it requires 179 Earth days. A night on Mercury lasts about 3 months and reaches temperatures as low as negative 173 degrees Celsius, or negative 280 Fahrenheit. And noontime temperatures can exceed 427 degrees Celsius, or 800 degrees Fahrenheit. So therefore, Mercury has the greatest temperature extremes of any planet. From the dark side of Mercury being, well, negative 173, and the sunlight side, or the zenith of the sun, at 427, that's a pretty broad range. So like our moon, Mercury absorbs most of the sunlight that strikes it, reflecting only about 6% into space, where the Earth's albedo is about 30%. So a little more about Mercury. Mercury's low albedo is characteristic of terrestrial bodies that lack or have very little atmosphere. Mercury is very dense, about 5.4 grams per cubic centimeter, which implies it contains a large iron core for its size, right? Large relative to its size. Mercury has cratered highlands, like the moon, and terrain that resembles the moon's maria. Mercury features include scarps. These are the results of crustal shortening, right? Just like that of the moon. Crustal shortening, as the planet cooled, it shrank early in its history, and the shrinking caused the crust to fracture. Fracture and buckle sometimes is what it's referred to. So acceleration due to gravity is a mere 3.6 meters per second squared. So if you compare that to the 9.8 meters per second squared on Earth, it'd be, let's just say, roughly a third of that on Earth. So your weight would be 1/3 of your weight. Venus. Venus is the second planet from the sun and is the closest neighbor in the solar system. Venus is the brightest object in the sky after the sun and moon, and sometimes it looks like a bright star in the morning or evening. I will say that Venus typically has a little reddish orangish hue to it. You can see it in this picture here. That's why I chose that picture. So Venus is a little smaller than Earth and is similar to the Earth internally. We cannot see Venus's surface because it is covered with thick clouds. However, space missions to Venus have shown that its surface is covered with craters, volcanoes, mountains, and large lava plains. So it was volcanically active. The surface of Venus is not where you'd like to be, with temperatures that can melt lead and the atmosphere so thick that it would crush you. It also has clouds of sulfuric acid that smell like rotten eggs. So the Venusian atmosphere is composed of mainly carbon dioxide, and thick clouds of sulfuric acid cover the planet. The atmosphere traps the small amount of energy from the sun that it's receiving, and almost completely traps the heat that the planet releases. This greenhouse effect has made the surface and lower atmosphere of Venus one of the hottest places in the solar system. So it's really kind of like saying it's the runaway greenhouse effect. Even though small traces of CO2 are important, too much of it, well, pretty much decreases or changes the total heat budget, and it traps it all internally. So why don't both Venus and Earth have hot, thick atmospheres? Well, because they have different concentrations of greenhouse gases in their atmosphere. So Venus is always found near the sun, It rises and sets each day, so it has the nickname of the morning and evening star. Scientists have found that Venus rotates backwards, which is called retrograde rotation. Picture to the left, this is from the Magellan spacecraft radar that enabled scientists to penetrate Venus's thick atmosphere to get surface views. So this is what the Venusian atmosphere, or excuse me, surface of the planet would look like. So brings us to Earth. Earth is typically identified as the blue planet as a result of being covered by 70% water. The Earth has an atmosphere with active weather driven by an imbalance of heat, along with the interactions of the water cycle. Earth houses life from simple unicellular cells to complex multicellular organisms. The Earth's average distance is 93 million or 150 million kilometers, miles to the sun, and this is what is defined as 1 AU, 1 astronomical unit. Earth's atmosphere is dominated by nitrogen, about 78%, and 21% oxygen. Earth is a rocky planet with an active interior, and this is what's driving plate tectonics. Earth has one moon and no rings. Earth is found within the Goldilocks region in space. It's just the right temperature for liquid water and life. And Earth's atmosphere provides a shield from dangerous ultraviolet light and meteoroids that could be harmful to life. Mars. This is the red planet due to oxidation of iron in the soil. It's literally rust. It's red due to its rustedness. It's rusted. Mars is a cold desert world. Mars is half the diameter of Earth, but has the same amount of dry land. Mars has seasons, polar ice caps, volcanoes, canyons, and weather. But its atmosphere is too thick for liquid water to exist for any long time or any duration on the surface. And there are signs of ancient floods on the Martian surface today. But water is very uncommon, except for in soils and in thick clouds. I also know that they can be found in poles. You can see these poles. You can find traces of water near the poles on the Mars surface. So here's the Mars Curiosity rover. And this has made a lot of news, headline news in the last several years. Mars orbits the sun at about 228 million kilometers, or about 1.52 AUs, astronomical units. So it's about 0.5 AUs further, right, Earth-Sun distances from the sun. A Martian day is just over 24 hours. Mars has volcanoes, impacts, crustal movement, and dust storms. Mars has two moons. They are called Phobos and Deimos. Mars has no rings. The Curiosity rover is currently on Mars today and sending back images of what it's discovering. Mars cannot support life as we know it. A key question is, though, could Mars have ever supported life in its geologic history? And with the evidence or the traces of water, that question is still kind of, let's just say, undecided. So some Kirk's soap, I think I found this watching a American Pickers, and it was Mars is peopled. And so back in the day, and Mars is peopled and they want Kirk's soap. Yeah, not that funny. And when I bring it back to this page right here, this is a document in the handout. We just looked at Mercury, Venus, Earth, and Mars, and you'll be responsible for knowing their AU, their distances. You'll be able to have access to this page. Understand their period of revolution. You'll need to, remember, revolving is an external axis. It's revolving around the sun. Their inclinations of orbit, their orbital velocities, right? So that's their linear speed as they travel through space. The period of rotation, right? That's determining the number of hours of a day. Their sizes, diameters in miles and kilometers. Their relative mass compared to that of Earth. Their densities, right? The inner planets are rocky and metallic components to them, particularly their solid cores. And their temperatures, and along with their satellites. And notice, Earth has one and Mars has two satellites. And there you have the information on the inner terrestrial planets.